All right, next, what I want to look at is our hyperbola, okay? Our hyperbola. Let's get rid of this for a moment. Now, what hyperbola are we talking about? Well, we're looking at number 7 on our drawing, and that would be this right here, okay? So there's number 7. I'm going to go ahead and need the origin. So I've got, oops, can I not do it? Here we go. All right, I'm going to cut that and bring it over here so we can all see it. Okay, now here's the equation. You'll notice that looks a little odd because we've got some fractions and things in there, but that's okay. That's going to happen on these depending on how you drew things. All right, we'll get to how all that happens in a moment. So let's take a look at our picture. You'll notice this parabola we're talking about right here. For one, notice I drew it symmetrical. On both of these, the tops end up 2 spaces apart, the bottom ends up 2 spaces apart. These come in a half a unit. The center point is actually going to be right here, okay? So that's my center. Here's my origin. It's at negative 1, 2, 3, 4, 1, 2, 3, 4, 5. So my center is at negative 4, 5, okay? Now, which parabola or hyperbola is this, horizontal or vertical? What is it? Horizontal, okay? So I already know quite a bit of my equation. I know it's going to be x plus 4 squared over a squared minus y minus 5 squared over b squared equals 1, okay? So now all I need to know is a and b. Notice I put the x squared positive, and a is under the x squared, under the positive term, because it's horizontal. All right? Well, now let's start figuring some things out. First of all, notice from my center to the vertex is half a unit. That means a equals 1/2. All right? Well, what is half times a half? 1/4, okay? So we now know we have x plus 4 squared over 1/4. And you don't need to simplify that any, just go with it, okay? And that's minus y minus 5 squared over b squared equals 1, okay? Now, here's the more challenging part, and that is getting it to hit the point that you want. All right, are there any questions up to this point? Okay, now, how do we get it to hit the point we want? Well, first of all, what point do we want it to hit? We want it to hit either this point, this point, this point, or this point. In fact, we want them to hit all 4 points. And because we drew it symmetrically, if we get it to hit any one of these, it'll automatically hit the other 4. Just kind of nice, okay? So, I'm going to just pick the closest one to the origin, negative 3, 1, 2, 3, 4. Negative 3, 4, okay? Now, as we did with the parabola and as we've done in the past with lines, okay, we're going to plug in the coordinates for x and y, okay? And really the question we're asking here is what b squared will make this hit the point negative 3, 4. Okay? So, that's why we're going to take this. we're going to replace the x and the y with our coordinates, -3 and +4. Okay? Now we've got some algebra, and the algebra can be a bit tricky. Just work on it, be careful, and you'll be fine. Okay? Use your calculator to help you out. Here we have -3 plus 4 is +1. 1 squared is 1. So I've got 1 over 1/4, which when I divide by a fraction, I flip and multiply, so that's 4. Okay? 4 minus, that's a -1. -1 squared is a +1. So that's 1 over b squared. And this whole thing equals 1. Alright? So let's keep going. Now I'm going to subtract 4 from both sides. I get a -1 over b squared equals a -3. Okay? Well, if both sides are negative, I can essentially divide by -1 and make both sides positive. So that part's taken care of. Okay? And then also, if I have 1 over b squared equals 3, what can I do to both sides to get b squared? What can I do? How about just take the reciprocal of both sides? Okay? Make that b squared over 1. That would make this other side 1 over 3. So b squared is now 1/3. Okay? So I can now write my final equation. Is it down here? No. I can now write my final equation, putting my x and y back in, but now I know what a squared and b squared are, because b squared is 1/3. Okay? So I'm going to replace that with my 1/3, and I'm done. Okay? I've got the equation that I need. Okay? So that is the hyperbola, yes?
What if, like, in your picture you only have one half, like the hyperbola? So
that will take care of with the bounds, and I'll show you how to do that here a little bit.